So in this video, I want to walk through a very simple connection between two computers here. So what I'm going to do is I'm going to connect from 192.168.0.147. I'm going to make a TCP connection to 192.168.192.10. And so usually the device that is initiating the connection is called the client. And then the device it's connecting to is called a server. But of course, once they're connected, it doesn't really matter who connected to who. They can both send data bidirectionally. And so what I'm going to do here is I'm going to start this connection from port 56208, which is just kind of a randomly selected port, and I'm going to connect to port 13 on the server. And then what's going to happen is the way this server is set up is when you connect to port 13, the server is going to send back just a little bit of text that has the time of day in it, and then the server is going to disconnect. And so this will basically let us walk through setting up the connection, getting a little bit of data from the server, and then walk through the disconnection. And so the first thing that's going to happen is the client is going to send a packet to the server to initiate the connection. And in that packet, it's going to give it the initial sequence number that the client's going to use. And normally it'll just pick a random number for the sequence number, but in this example, I'll just start with the sequence number equal to 0, just to kind of make things simple. And to tell it that this is the initial connection, it sets this SYN bit. These are all the flag bits that are in the TCP header. And one of the flag bits is the SYN bit, which stands for synchronize. And so it sets this SYN bit to tell it to synchronize. This is a new connection, and the sequence number is going to be 0. And then the server is going to respond by acknowledging that. And so it's going to send a packet in the other direction with the acknowledgement bit set. And so it's going to say acknowledge. And then it's going to use this acknowledgement number to tell it the next sequence number it expects. So it's going to say the acknowledgement number is 1. Because the client just said its sequence number is 0, so the server is going to acknowledge that and say the next sequence number it expects is 1. In this same packet, the server is also going to set its own SYN bit and send its sequence number, which in this case I'll just say 0, but again, it's going to pick a random sequence number. And then the client is going to acknowledge that with an ACK with the acknowledgement number of 1. And it's going to set its sequence number to 1. And there's no data in this packet, so even though the sequence number is 1, the server doesn't receive any data, so it's still expecting the next byte of actual data to show up with sequence number 1. And so at this point, with these 3 packets back and forth, the connection is established. So at this point, the connection's established. And so once the connection is established, both sides can go ahead and send data back and forth. And so in this particular case, there's some software running on the server that whenever anything connects to port 13, it's going to send back the time of day. It's just going to send back a string with the time of day in it. And that's going to be just some data, and in this case, let's say it's 22 bytes long. So there's 22 bytes of data that contain the time of day. And so the sequence number for this is going to be sequence number 1. But then what's going to happen is the client is going to acknowledge that with an ACK. And the acknowledgement number is just going to say what the next sequence number it expects. So the sequence number it was expecting was 1, right? Because the client initially sent sequence number 0 as the SYN, and so the client is now expecting 1 to be the next sequence number. And so it acknowledges that, saying it's acknowledging and saying that 1 is the next number it expects. And now it's receiving something with sequence number 1, but it's receiving 22 bytes. And so what it's going to do is it's going to respond saying that the next thing it expects is 23. So it's going to acknowledge and say that the next sequence number it expects is 23, because it's already received bytes 1 through 22. And so the next thing it expects is 23. And then at this point, the server has sent the time, and so the server is going to go ahead and disconnect. So this is kind of the end of sending data, and the server is now going to disconnect, and what it does is it sends a packet with the fin bit set And in this case, the sequence number is going to be 23 because that's the next sequence number. And so the fin bit is just another one of these bits that are in the TCP header, and its purpose is to say that the connection is finished or we want to disconnect. And so the server wants to disconnect, so it sends a packet with the fin bit set, and it's sequence number 23. And then the client is going to acknowledge that. So it sends an ACK with the acknowledgement number of 24. Because it just received 23, it's now going to send back saying, okay, I got that. The next thing I'm expecting is 24. And so at this point, the server has closed the connection, so the server can't send any more data to the client. And now the final thing that happens is the client closes the connection as well. So the client is going to send another packet here with its fin bit set. So the server sent a fin, now the client's turn to send a fin, and then the server will finally acknowledge that. And so when the client sends this fin, it's going to set the sequence number to 1, because if we go back up here, remember the first thing the client sent was this SYN with a sequence number of 0, and then the server acknowledged that, saying the next thing it's expecting, it's acknowledging it, the next sequence number it's expecting is 1. And then the server doesn't send, or excuse me, the client doesn't send anything other than acknowledgement. So it's just sending this acknowledgement, this acknowledgement. It's not sending any data. All the data was in this direction. So at this point, the next sequence number that the client is going to use is sequence number 1. So it sends its fin with sequence number 1, and then the server acknowledges that, saying that the next sequence number for the client is 2, and at that point the connection is completely closed. And so I actually set this connection up, and we can take a look in Wireshark. I captured it in Wireshark. And so I would encourage you to try this as well, is go into Wireshark and try to capture some TCP traffic and see what you see. But what we see here is that the first 3 packets are the setting up the connection. So here it shows you what flags are set. So you can see the SYN, and then the response with the SYN ACK, and then the response with the ACK. And so after these 3 packets here, the connection's established. So we have the SYN with the ACK, and then the ACK. And at that point, we're established. And then at that point, the server can send, and so this is from the server, 192.10, can send to this destination the actual data. And if you look down here in the data, you can actually see it has the time and date, which is what this particular server does. And then you can see the acknowledgement again from the client. And then the last 4 packets are the fin from the server, the ACK from the client, the fin from the client, and then the ACK from the server to close the connection. And Wireshark is nice too because it tells you the sequence numbers and the acknowledgement numbers in each direction as well. So these should all match up with the scenario that we just walked through. And one of the other nice things that Wireshark does is you see it's saying sequence number 0, but if we actually look inside the TCP header, the sequence number, it says sequence number 0, and then it says relative sequence number. And if you actually look at the data, you can see it's actually this 5105B621. So it's picking this kind of random sequence number, but Wireshark is nice enough to just sort of subtract out that starting sequence number and then show all of these numbers as relative. So it's a lot easier to follow that way. And so you can see the server is starting with sequence number 0, even though it's really this crazy number. And then the acknowledgement the client is starting with that sequence number 0, and then the acknowledgement from the client is saying the next thing it's expecting is 1. When really, so this is B621. If we look at the client and we look at the relative ACK number, it's actually saying B622. So in reality, it's adding 1 to that crazy number, but Wireshark is nice enough to show us the sequence numbers and acknowledgement numbers as kind of more friendly numbers, or starting at 0. So again, I would encourage you to download Wireshark and play with it and try and see if you can see TCP in operation like this for yourself.